I can't walk all the way from Davies Road all the way.
I'm not talking. I'm talking about Packer. I'm not mad. I get it. I'm not saying anything. But I'm saying if you were that scared of Packer, just run or something. I don't know. Okay. So, starting to kind of connect ideas here. But that'll continue in the next couple of days too. So this chart we had last time, I had put like +1 sigma here, like +1 standard deviation, +2 standard deviation, +3 standard deviation. I kind of regret now not putting Z's. Z is just the number of standard deviations. We haven't like learned it yet, but I should. I wish I'd had like the foresight to put that there. But this is the same exact chart. So this is the mean. This is 1 standard deviation above, 2 standard deviations above, 3 standard deviations above. We got all the percents that we had last time. So there are like these 5 things, and I got them all filled in for this one. But really, I can leave 1 or 2 blank and have you fill in based on some information. Let's just start kind of connecting what these are. So it is nice to be able to conceptualize what's going on, like without the formula. So what this is saying here. This is our data point. This is the mean. How far apart are those? 100 apart. Every standard deviation is 50. So how many standard deviations apart are there? There's 2. So they're 100 apart. Every standard deviation is 50, so they're 2 standard deviations apart. And are we above the mean or below the mean? Above. So then we end up with a z-score of +2. Positive because we're above. And then a +2 z-score puts us here. Remember, percentile is the percent below. So if you're like I'm in like the 96th percentile maybe for height, or Packer would be in like the 10th. So it's the percent that you're above. There was that one question on the homework last time. If you were like the 90th percentile blood pressure, that's not great, right? Because you don't want your blood pressure to be that high. If yours is higher than 90% of people, that's not ideal. So z-score of 2 puts you here, and then your percentile is adding up to the left. So you can add up all these, or remember you can add up these 2 and subtract from 100, right? If you wanted to do this with the formula, I don't even know what I would left blank here, so it's kind of hard to tell. But if I were just to kind of plug in and go through these, the z-score is 2, x bar. No, that's backwards. Sorry, this isn't the formula I'm used to. I'm trying to adjust to the notes. So this would be 200 minus 100 over 50. And then like that matches up, right? This is what we're saying, how far away is it from the mean? And then do 100 divided by 50, and this would say 2 equals 2. So I'm just going to prove to you that it works. So yeah.
What formula are you used to?
It's the same formula, just different notation. It's the notation I'm used to. Alright, let's say x is 1200, the mean is 1000, and the standard deviation is 1100. The standard deviation is 100. See if you can tell me the z-score and the percentile. Right now they're nice and friendly numbers, right? They won't necessarily be going forward. This is what you guys have to use the notes, right?
Yeah.
Your quizzes are graded. They're not power school yet. So you guys are done. If you want to come over here, you can. Or just wait till the next hour. Okay, so if you're kind of thinking through it logically, I am 100 points above the mean, and every standard deviation is 100 points. So how many standard deviations above the mean am I? 1, so your z-score is 1. And if my z-score is 1, I'm here, and the percentile is the percent below that. So you add all these up, you get 84. If you want to use the formula, that works too, and you should get to know the formula because it's not always going to be like hundreds, you know. So z is x minus x bar over standard deviation. So z is 1100 minus 1000, which is what we're saying, like how far apart are they? Divided by 100, and that gives me 1. So it's good to understand like where it's coming from. But there are times you have to use the formula too, because the mean will be like 61.73. So the z-score here is 1, and the percentile will be 84. Alright, let's say you got a chem test and a stats test. On the chem test, you got a 70. The mean was 55, and the standard deviation was 5. The stats test kind of looks like you did better. You got an 80, but the mean was 72, and the standard deviation was 4. So I want you to tell me the z-score and the percentile for both of those, and which one you did better on in comparison to your classmates. Like obviously 80 is a higher score, right? But percentage, like relative to your classmates, which one did you do better? So find the z-score and the percentile on that way. You won. The Duro?
Yeah.
That's sweet. How'd you do?
Second.
So we like wait for the files and lost to them.
Lost to a kid that I should be able to.
You shouldn't have lost to them. Second still.
Yeah. 3 sets, 6, 7, 6, 1, and then we put a tiebreaker and extra basketball.
Oh, really?
He called a very interesting timeout after the set. It took 15 minutes. So he got the 5 minute, or he took 10 minutes, got 5 minutes between sets, and then took the extra 5 minutes because he was hurt. And then came out and just listened to
But he was fine.
Yeah.
Great. Okay, so if I'm looking at this, the chem test, 70 minus 55 would be 15. Divided by the standard deviation is 5, so you are 3 standard deviations above, which is 99.85 percentile. Not 100, hold on. And then for the stats test, 80 minus 72, so you did 8 points above the mean. Standard deviation is 4, so you did like 2 standard deviations above the mean, which, you know, is garbage. It's only the 97.5th percentile. So you did relatively better on the chem test, actually. Even though your score was higher on stats, your percentile was higher on chem. Questions on those? Alright. Alright, then I can start leaving like other things blank. So let's say I told you like 34%. Your standard deviation is 8 and your mean is 50. Can you find the missing data there? Obviously the video will be up on Schoology, but I'll put the spreadsheet up too. I'll link to it, and then I'll also put the answers to your quiz up there, so that if you got one wrong, like I like the questions on it too. But if you're studying and you got one wrong, you're like, wait a minute, what was I supposed to do? Or we have a test on Friday.
For the stats units, always going to be like shorter than calc. Or they get to like about the same.
I'd say shorter usually, but it can depend. I should have gone faster. Probably. So it should be a little bit better.
So maybe we work through a lot of it.
Yeah. Okay. So if the percentile is 34, then I've got to look and see where is there 34 behind. That doesn't even work. I don't know what's
Yeah, I
happening.
was like,
Well, because we wasn't sure if we were.
You were like, yeah, you went
yeah.
Yeah, okay, that's fair. Okay. Make it 16%. Try again with 16%. So that makes more sense, right? Hopefully. So 16%, I gotta see where the 16th percentile is. Well, if I'm here, I got 0.15%. If I go to here, now I've accumulated 2.5%. If I go over to here, now I've accumulated 16%. So this part down here is 16%, which means that my z-score is -1. And then that helps me with finding the x. So you can kind of do it two ways. This means I have one standard deviation below the mean. Below because it's negative. The mean is 50, every standard deviation is 8. So if I'm one full standard deviation below the mean, then I have to be at 42. Or if you want to do it like algebra-wise, you got your formula z equals x minus x bar over standard deviation. So -1 equals x minus 50 over 8. And then I would multiply both sides by 8. Those cancel, and you'll get -8 equals x minus 50. And then if you add 50 to both sides, look at us using algebra. You get 42. So it's nice when you can eyeball it and kind of just look at it, and I like to do that because it means you understand the concepts. But you do need to know this also for when the mean is like 50.13 and x bar is 47.9. You have to. There's some of the decimals you just can't do. Easily. Probably could if you had to. Alright, so this was -1 and 42. So let's say your mean, let's do this. The z-score is 0. And the mean is 100. What is the percentile going to be if your z-score is 0? You are 0 standard deviations away. Look at you raising your hand. Gavin? Nice. Love it. 0 standard deviations away means you're not above the mean, you're not below the mean, you're on the mean. So 50% is below that. If you are on the mean, you are 0 units away from the mean. So what is x going to have to be? It's going to be 100. And then does this matter? Standard deviation doesn't really make a difference. This could be anything. Because if you're on the mean, we're not counting how many standard deviations away we are. So it could be anything. The question would be, it would probably, I don't think it would be on there, but it would probably be something like, if the z-score is 0, the standard deviation is irrelevant, true or false. Something like that. Alright, let's say z-score is 1. mean is, no wait, X bar is 600. Standard deviation is 50. Can you fill in the other two things? I don't want to do one with like weird decimals, just make sure you can actually do the algebra if you need to. So if z is 1, are we, let's talk about this too, just make sure. Are we above or below the mean if z is 1? Above. So is our percentile going to be above or below 50%? It's going to be above 50%. And if we look at that chart, one standard deviation to the right, we have to add 34% more, so that's 84%. And if I'm one standard deviation above the mean, and every standard deviation is 50, that means I'm 50 above the mean, so the mean must be 550. Questions on? Give me like thumbs up, I get this, thumbs down, I don't know what you're talking about, sideways, don't flip me off. Too early in the year for that, too early in the day. Alright, cool. Alright, let's say your z-score was 1.23, x is 0.57, your standard deviation is 0.13, and then we're not going to be able to do the percentile for this one yet. We don't have those tools until tomorrow. So don't worry about that. Let's see if you can tell me the mean. So I'm just making sure you can do the math formula if you need to. X bar is the mean. So I put it like up here. This should all be some x is the data point. X bar is the mean. That's how I roll. So you can think about this two ways. Some people would say multiply both sides by 0.13. And those will cancel. And some people would say put this over 1 and cross multiply. But don't you just end up doing 1.23 times 0.13 either way. So it doesn't really matter which way you think about it. It's the same idea. So if I do 1.23 times 0.13, I get 0.1599. Here's a fun thing about stats that we'll talk about. Where do you round? So the AP, like legit, I was at a conference and like the head of the AP graders was there. He said round to where it makes sense to you. I was like, what makes sense to me is different than what makes sense to you. He's like, I don't have an answer for that. Round to where it makes sense. Which to me is garbage. So like my response to that is I'm just not gonna round very much at all. Like, I would way rather you guys put. There was someone one year that just refused to round. So they'd be like, their answers would be like 10 dozen places long just because that's where the calculator stopped. They wouldn't have known. But if you're ever in doubt, should I round or not? I would say don't. Like it's always better to be more precise than less. I didn't appreciate that answer. So, like some of you might put 0.16 there, and I think it's fine. I'm just getting into the rounding bit. And then I think I would probably subtract the 0.57 from both sides. So you'll have negative x bar. Make sure you realize your x bar is still negative there. So I get negative 0.4101. I don't care about negative x bar. I want positive x bar. So x bar is 0.41 is more than fine. But just to be super careful, you might want to put 0.4101. And then just kind of look and make sure it makes sense. And what I mean by that is our data point above or below the mean? It's above, so it's above. Should our z-squared be positive or negative? Positive, and it is. Or like if I forgot to put that, well, that would still work. But sometimes it doesn't mean you did it right. But sometimes you look at mistakes and you kind of think, does this make sense compared to everything else? How many had 0.41 there? Questions on it? Or like anything over there? Alright, so you guys have time to finish up like the second half of 1.5, I think was that, and then the first part of 1.6. So there's a lot of these words in there. You have to work on that. I also gave you assigned 3 cons. We have notes tomorrow, notes